Hello, my good fans out there. I am Dr. Diajun, your regular lecturer on chemistry on social media. My last lecture was on general gas equation and some calculations based on it. But right away, we shall be discussing on the titled ideal gas equation. In general gas equation, as we said before, is a combination of both Boyle's law and Sar's law. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to the temperature, but the pressure remains constant. While in Charles' law, he stated that the volume of a given mass of gas is directly proportional to the absolute temperature, the pressure remains constant. So the two of them combine to form the general gas equation, which is expressed as it is on the board here. P1 V1 over T1 equal to P2 V2 over T2. So now we have ideal gas equation. Let us see what we have as we go by my note. In all calculations or in all measurements that are involving gases, four quantities are always considered. And these quantities are volume, pressure, temperature, and the number of moles. But out of these four quantities, three appeared in general gas equation, which is the pressure, temperature, and volume, as it is expressed in the board, as I said before. But for ideal gas equation, it is the product of the pressure and volume divided by the temperature, which is a constant, and that volumes of all gases at the same temperature and pressure contain equal or the same number of molecules. And it is also a fact that 1 mole of any gas at STP occupies a volume of 22.4 dm cube. So for this, ideal gas equation is expressed as PV equal to equal to nRT. This is ideal gas equation. So it means you can define ideal gas equation by saying it is the product of pressure and volume equal to the product of number of moles, ideal gas molar constant, and the temperature. So now, you can now see that when we break down this here, the R is the molar gas constant, and it has a value of 0.082 atmosphere per dm cube per Kelvin per mole. Then the P is the atmospheric pressure, which is a constant at 1 atmosphere. Then the V is the volume in the dm cube. And the T is the temperature in Kelvin, which is equivalent to 273 Kelvin. The N is the number of moles in the gas. So now, considering this equation, at STP, 1 mole of a gas will now occupy R equal to PV all over NT. Now, this equation is derived from here. We are making the R at the subset of the equation. That's why you see it now as PV all over NT. So I said this is derived from what? This equation which is here. Now we want to find out or confirm the value of the molar gas constant, which is here. So now, following or going by this equation now, R is equal to P, which is 1 atmosphere pressure, multiplied by the volume, which is 22.4 dm cube, as we have in above. Then we have all over the number of moles is 1 mole which is here, multiplied by the Kelvin temperature, 273. If you multiply this out and work it out mathematically, you will arrive at 0.082 atmosphere per dm³ per Kelvin per mole. So the R is the molar gas constant. So if you compare ideal gas equation to general gas equation, in general gas equation, 3 parameters are there. While in ideal gas equation, we have the 4 parameters. We have the pressure, the temperature, the volume, and the number of moles. So please like it. Share this video to your friends. Subscribe to my YouTube for more lectures. Thank you.